and welcome to this session on making of keys. Let's begin with the session.
Let us look at the objectives of this session. At the end of the session, you will be able to list the type of keys, state the specifications of keys, state the advantages of key. Key is a metallic wedge inserted between a shaft and hub parallel to the axis of the shaft. The size of the key is proportionate to its shaft diameter. Keys secure the shaft with hub or pulley while transmitting power to prevent any relative motion between them. Key set is a recess in the shaft and keyway is the recess in the hub between which a key is housed securely when both are mated. The different types of keys are classified as follows: sunk key, saddle key, round key, splines key, tangent key, Kennedy key. The most common types of keys are parallel key, gib-headed key, woodruff key, tangential key, hollow saddle key, flat saddle key, round key, circular taper key, feather key, peg feather key. Parallel key. This is the most commonly used key used for transmitting unidirectional torque. Parallel keys or parallel sunk keys are sunk into the shaft for half its thickness. Parallel sunk keys can either be rectangular or square sections with or without taper. It is one of the easiest key to install and is inexpensive. But the keys need to be ideally held by a set screw through the hub because vibration or rotational direction reversal often push the key out. Parallel taper sunk keys have a taper of 1 in 100 mm on the top face. Now, let us learn the approximate proportion of parallel keys. If D is diameter of the shaft, width of the key is W, which is equal to 1/4 of diameter plus 2 mm, and nominal thickness is T, which is equal to 2/3 of width mm. For example, diameter of shaft is equal to 40 mm. Width is equal to 1/4 of 40 plus 2, which is equal to 12 mm. Thickness is equal to 2/3 of 12, which is equal to 8 mm. Gib-headed key. Gib-headed keys are machine keys that have a projected end which serves as stop mechanism on a rotating shaft. This key has taper 1 in 100 on the top face. It is driven on the keyway by hammering on the gib to have a tight fit. A gib-headed key can be withdrawn easily and used for transmitting more torque. It is not suitable for high-speed applications. Let us now learn the approximate proportion of gib-headed keys. If D is the diameter of the shaft and T is thickness of the key, height of the gib is H is equal to 1.75 T mm. Breadth of the gib B is equal to 1.5 T mm. Width of the key W is equal to 1/4 of diameter plus 2 mm. Nominal thickness T is equal to 2/3 width. Angle of the chamfer is equal to 45 degrees. For example, diameter of shaft is equal to 46 mm. Width W is equal to 1/4 into 46 plus 2, which is equal to 11.5 plus 2, which is equal to 13.5 rounded off to 14 mm. Thickness T is equal to 2/3 into 13.5, which is equal to 9 mm. H is equal to 1.7 into 9, which is equal to 15.75 rounded off to 16 mm. B is equal to 1.5 into 9, which is equal to 13.5 mm. Woodruff key. It is a semicircular key used for transmitting light torque. This key is particularly useful on tapered fittings or shafts. Let us learn about the approximate proportion of Woodruff key. Radius of the key R is equal to D by 3 mm. Thickness T is equal to D by 6 mm. For example, diameter of shaft is equal to 30 mm. R is equal to 30 by 3, which is equal to 10 mm. T is equal to 30 by 6, which is equal to 5 mm. Hollow saddle key. One of the face of this key has a curvature to match with that of the shaft surface. It has a taper of 1 in 100 mm and is driven in through the keyway. The hub is held on the shaft due to friction since it doesn't have a key seat. This key is useful only for light-duty transmission. Flat saddle key. This key has a rectangular cross-section. For fitting this key in the assembly, a flat surface is machined on the shaft. This is stronger than the hollow saddle key. This is not suitable for heavy-duty transmission. Let us learn about the approximate proportion of flat and hollow saddled key. If D is the diameter of the shaft, width of the key W is equal to 1/4 of diameter plus 2 mm. Nominal thickness T is equal to 1/3 of width. For example, diameter of shaft is equal to 24 mm. Width is equal to 1/4 into 24 plus 2, which is equal to 8 mm. T is equal to 1 by 3 into 8, which is equal to 2.7 or 3 mm. Tangential key. These keys are used when very high torque of impact type is to be transmitted in both directions of rotation. A tangential key consists of two taper rectangular wedges positioned one over the other in opposite directions. Two sets of keys are fixed at 120-degree angle. The broad side of the key is directed along a tangent to the shaft circle, while the narrow side sits along the radius of the shaft. Round key. It is of cylindrical cross-section and is used in assemblies to secure the mating components where the torque is light. The key is fitted parallel to the shaft into the drilled hole made partly onto the shaft and partly onto the mating part. Let us learn about the approximate proportion of round key. If diameter of shaft is d, diameter of the key is equal to small d equal to 1 by 6th of diameter. For example, diameter of shaft is equal to 30 mm, then diameter of key is equal to 1 by 6 into 30, which is equal to 5 mm. Circular taper key. This is like round key but with a taper 1 in 100 mm. Feather key. This is parallel key with rounded ends. This is useful when the hub or pulley has to slide axially on the shaft to some distance. Peg feather key. It is a parallel rectangular key having a round peg at the center or one edge of the key face. The peg will fit into the hole of the shaft or stationary member of a unit assembly to prevent the sliding of the key. Let us learn the advantages of the keys. Cheap manufacturing cost, standardized, best suited for medium to high torque transmission, easy mount and dismount, hence easily reusable. Let us now learn the disadvantages of keys. Not suitable for alternating directional loads and shocks. To transmit axial force, it needs a stop lock. May introduce shaft imbalance. Keyways introduce stress point due to notch effect and reduce shaft strength.
To recap, we have learned to list the types of keys, state the specification of keys, state the advantages of key. So that's all about making of keys. Hope you have understood all the concepts and exercises. See you in the next session.